In this lesson, 4.3, we're going to talk about congruence and how it applies to triangles. So for this lesson, we are going to be using the definition of congruence. So the definition of congruence reads, two triangles are congruent if and only if, because remember definitions are always biconditional. So two triangles are congruent if and only if corresponding pairs of sides and angles are congruent. So that means that we need three sets of congruent sides and angles. So every single side needs to have a corresponding congruent side in the other triangle, and every single angle needs a corresponding congruent angle in the second triangle. So first we're going to look at how congruent statements are written, because the order of the name of the triangle is very important here. It's going to have to be with our corresponding angle vertex as we write it. So the first triangle can kind of be named however we want to. So in this particular setup where we have triangle with vertices A, B, and C, and a triangle with vertices R, S, and T, how we name the first triangle is going to determine how we have to name the second triangle. So if I look at the first triangle and I decide to name it A, B, C, whenever I name the second triangle, I need to make sure that I'm matching up my corresponding parts. So if I started with the letter A, and I look at the marking that's on the letter A, notice that it has 3 marks on its angle. So the corresponding angle is going to be marked that exact same way. So in the second triangle, the corresponding angle is angle T. So when I name my second triangle, since A came first, T has to come first. So after A, the next angle I marked was angle B. And so what I have to pay attention to is how I get from A to B. So notice that I go down this side that is marked with 2 lines, and then to this angle that's marked with 1 angle marking. So I need to follow that same path in the second triangle. So I start at T, I go down the 2 lines to the angle that's marked with 1 angle. And so that's going to lead me to angle S. So the next letter in my triangle name will be S. So B corresponds to angle S. All right, and then from there, I have one more vertice to name it by. So I go down the side with 3 markings to the angle that has 2 markings. And that takes me to angle C, vertice C. And so if I do that in the second triangle, I start at S, and then I go down that same side to the angle that has 2 markings, and that takes me to side R. So if I name this triangle as ABC, the first triangle, then its corresponding congruent triangle is triangle TSR. So the way that we name triangles is very important. So let's say I used a different setup of the first triangle. So if I had named this triangle BAC, I would want to make sure that I used those same corresponding parts. So if I start with angle B as my first vertice in my first triangle, then I have to make sure that I match it up with its corresponding parts. So B corresponded to S. Then if I use the letter A corresponded to T. And finally, C corresponded to R. So if I name it BAC, I have to name the other triangle STR. So those same vertices have to stay lined up. The way that we name them tells us exactly which parts are congruent. So in this second one, we have a congruent statement. This says that triangle DEF is congruent to triangle MNO. We are going to mark and label those congruent parts. So here I already have vertices that are labeled with the letters, so triangle DEF and triangle MNO, and I want to mark and label congruent parts. So I start with how it is named. So the letter D corresponds to the letter M. They're both in the first position, so that's going to be my first set of congruent angles. So I'm going to mark angle D with 1 congruence marking. And then in the second triangle, I'm going to mark angle M with that same single marking. The next letter in the name is angle E, and that corresponds to angle N. So since it was the second one, I'm going to put 2 congruent marks in angle E, and then I'm going to go to the second triangle and mark that same 2 marks. The final letter in the angle name is F for the first triangle and O for the second triangle, so those correspond. So I'm going to put 3 markings on each of those angles. So angle F gets 3 markings and angle O gets 3 markings. So now our congruent angles are marked with the same mark but in the 2 different triangles. So from the definition of congruence, we have 3 sets of congruent angles. We also have 3 sets of congruent sides. So we want to make sure that we mark the sides with those same number of tick marks. So if I think about, if I can just choose one, and if I put a single marking on segment DE, now if I go back up to my letters also tell me congruent segments. So if I use the first 2 letters, DE is going to be congruent to MN, so I'm going to mark that with the same single marking. If I put 2 marks on EF, that's the second 2 letters, so EF would be congruent to NO, so I'm going to put 2 marks on it as well. So the same number of little slashes to show that those are corresponding parts. And then finally, if I put 3 slashes on DF, DF is the first and the last, so that will correspond to MO. So I want to make sure that I have corresponding parts set up with those same markings. So your triangles aren't always going to be in the same orientation like these are, where our angles exactly line up, and that's when the names of them is going to be even more important. Alright, so here's an example of 2 that are not set up exactly the same, but these are trapezoids, and we'll talk about what makes a trapezoid. But just based on this, it has 4 letters, so notice there's not a little symbol in front, but the 4 letters tells me that it has 4 vertices. So it's not just a triangle, but these are congruent figures based on how it's written. So ABCD is congruent to KJHL. And we're going to find X and Y. So to find X, I want to look at what segment it is positioned on. So the expression that has an X in it, 4x minus 3, is on the segment KJ. So I can use that name to help me figure out which segment corresponds to segment KJ. So KJ was the first 2 letters of the second quadrilateral name. And so the first 2 letters of the first one are AB. So that side, KJ, is going to correspond to AB in the other expression. And so since those are congruent segments, I can set those measures equal to each other. So AB had a measure of 9 centimeters, and KJ had a measure of 4x minus 3. So I used this congruent statement to help me set up this equation. So AB is congruent to KJ, so their measures are equal. And then I'm going to solve this equation. So the first thing I need to do is add 3 to both sides. So 9 plus 3 is 12, and 12 equals 4x. So 4 times x, I'm going to divide to cancel that out, and 12 divided by 4 is 3. So the value of x is 3. I just double check, make sure that's what it asked me to do, and it did. It said find x and y. So now that I used that segment AB is congruent to KJ to find x, I'm going to look at where y is. So y is an angle measure, and the angle here is angle H, is the angle that it corresponds to. So if I look at where H is positioned in the name, it is the 3rd letter. So angle H is going to be congruent to angle, the 3rd letter in the first one is C. So angle H is congruent to angle C. So their measures will be equal. So I'm going to say 5y minus 12 equals, and then I'm going to go to this other figure and look at angle C, and it had a measure of 113 degrees. So I set those 2 things equal to each other, and then I can solve to find the value of y. So for this equation, the first thing I need to do is to add 12 to both sides. And that leaves me with 5y equals 125. And then to get y by itself, I'm going to divide both sides by 5. So the value of y is 125 divided by 5, which will give me 25. So we use the names of our figures, our congruent figures, to help us figure out what those corresponding parts are. So here is another theorem that we have to add to our list of things that we know for Unit 3. This is called the third angle congruence theorem. Remember that the names usually have a lot of information about what it's going to say. So this theorem says if two pairs of angles are congruent, and that's talking about within a triangle. So if you have two triangles where two pairs of angles are congruent, then the third pair must also be congruent. And that's because of the angle addition postulate. There's only 180 degrees in each triangle. So if you already know that two of the sets are going to be the same, then that third set's also going to have to be the same. So here, if I look, I'm going to use this theorem because I have two sets of congruent angles marked. The angle right here that's marked as 100 degrees. There's another congruent angle in the second figure. Then I also have an angle in each that's marked with two little dash marks here. And that's in this triangle, that's measured at 45. That same marking is in the second triangle, so that means that this angle would also have to be 45 degrees. And so since those angles are the same, that means that the third angle would have to be the same as well. So if I think about the triangle sum, so the triangle sum theorem, that triangle sum theorem says that the three angles in a triangle add up to 180 degrees. So to find this third angle, I'm going to add together 100 plus 45, and then I'm going to take that away from 180 to find that extra angle measure. So that's going to be 180 minus 145, and that tells me that the last angle in this figure, this triangle that we're looking at first, that last angle is going to be 35 degrees. So since we had two sets of congruent angles, the third angle will have to be congruent as well. So these two will have to be the same. So to find the value of x, I'm going to set those two expressions equal to each other. So my equation that I solve is going to say 35 equals 4x minus 9. All right, so to solve this equation, I'm going to add 9 to both sides. All right, so 35 plus 9 is going to be 44. So that says 44 equals 4x. So to get the x by itself, I divide by 4, and I find that x equals 11. So the value of x that's going to make those two third angles congruent is 11. So the third angle theorem lets us know that if we have two sets of congruent angles, the third one's also going to be congruent. All right, the last thing we're going to go over in this section is a proof. So this proof, we have three givens. We have that segment MN is congruent to QP. So as we use these, we are going to start marking our diagram. So sometimes your diagram will already be marked, but a good practice is to redraw the diagram and then mark it as you go so that you know what things you've used. So the first thing I'm going to do is I'm going to introduce a given. And so since all of these, we have a congruent given, we have a parallel given, and we have a midpoint. So since those all three say different things, I'd like to introduce them on different lines. So the first thing I'm going to introduce is that given that says congruent. So MN is congruent to QP. So once I write it down and give it my reason, in my proof, I'm going to go on and mark it. So segment MN is congruent to QP. So our goal here is going to be to say that triangle MNO is congruent to triangle QPO. So these are the two triangles we're looking at. And what we have to use is the definition of congruent triangles which says that all sides and angles of one triangle have a corresponding congruent side or angle in the second triangle. So in order to use this definition of congruent triangles to prove that these two triangles are congruent, I'm going to have all three sides listed as congruent in my proof and all three angles listed as congruent in my proof. All right, so now I have one side. So one side is listed as congruent. There isn't really anything else I have to do because that's one of the things that I need to use the definition. So after that, I'm going to go on and I'm going to introduce my next given. So the next given says that MN is parallel to PQ. So in the previous unit, when we were talking about parallel lines, we were looking at angle pairs. So these parallel lines should give me some angle pairs to work with. So what I'm going to do is I'm going to kind of isolate that part of my diagram. So that's the line MN, and it is parallel to the line PQ. So I have some segments that run diagonally through that diagram, and I'm going to use those to find some angle pairs that would be congruent. So if I think about the diagonal, that kind of would have a negative slope. And within the triangles, so we have a triangle up at the top and we have a triangle down at the bottom. I know that's not perfect, but thinking about that, the angle that I need that is on those parallel lines and transversal, but also in this figure, and since there are multiple angles at each letter, we have to use 3 letters. So with this one, looking at the diagram, either one, the parallel lines that I isolated or that original, what we're looking at are kind of these angles that form a Z. I like to call them Z angles because they're like the peaks of that Z, the letter Z. This is backwards, but it's those little angles within the Z. That's our first set of congruent angles. So in this top triangle, that angle would be NMO. So the first thing I'm going to say is angle MNO is congruent to, and then the angle at the bottom, so MNO, that would be congruent to angle PQO. So those angles, since they're those peaks of the Z, the angle pair that those match is the alternate interior angles. So that is the alternate interior angle theorem that tells me that when the lines are parallel, the alternate interior angles are congruent. So that's my first set that I can use with those parallel lines. So now if I go and I isolate the other transversal, so let me get rid of what I had already. The other transversal would have like a positive slope if we're thinking about equations. And we're going to use that same angle pair because we're still talking about these two triangles, one at the top, one at the bottom. So within these two triangles, we're looking at those Z angles again. So one at the top, and so since this is the second triangle, or the second set of angles that I'm marking, I'm going to use 2 markings at the top and 2 in that corresponding angle down at the bottom. So those are the angles that formed the letter Z. All right, so if we think about the letter Z made with those parallel lines. All right, so for this one, now we're going to name those angles that I marked with 2, which is, all right, so I named this one wrong. When I did PQO, O for the one marking, I should have done NMO instead of MNO. So NMO. This one will be MNO. So MNO has 2 markings. So the corresponding angle in the second one will be QPO. So angle QPO. So sorry about that mistake, but the way we name things is very important. And that was also the alternate interior angle theorem. All right, so based on my parallel lines, those are the only 2 angles that I can say are congruent. So now I have, just keeping track, I have one side congruence statement and I have 2 angle congruent statements, and I need 3 of each. So I still need 1 set of angles and I need 2 more sets of sides. So I ran out of things that I can do with my parallel lines. So let's go on and use our last given, which says that O is the midpoint of PN and MQ. So O is the midpoint of MQ and PN. And then I want to use this and make sure that I say everything that I can about this statement now. All right, so if O is the midpoint, we have to think about everything that we know about midpoint. And the only thing we have that deals with the midpoint is the definition. So the definition of midpoint is that it's a point that divides a segment into 2 congruent pieces. So it's exactly in the middle. It's going to make the 2 sides of the segment that we're working with congruent. So we're given 2 different segments here. We're given MQ. So if we look at the segment MQ and O being the midpoint, the 2 pieces that it divides it into will be congruent. So for MQ, the 2 congruent pieces will be MO and OQ. So the first way that we use the definition of midpoint is by using the first segment. So MQ was the first segment that it told me it was the midpoint of. So MO is congruent to OQ. In each triangle, I already have a side marked with 1 marking. So this one is going to have 2 markings. All right, the next segment that it is the midpoint of is PN. So O is also the midpoint of PN. So those 2 segments that it splits that into will also be congruent. So if I look at O being the midpoint, the 2 segments are PO. So PO. So PO will be congruent to NO. So those 2 segments are going to be congruent. And so since there was already a side that was marked with 1 and a side that was marked with 2, those will be marked with 3 markings. And so both of those use the same reason, so I can put those on the same line. I could have done the same thing up here when I used alternate interior angles twice. So remember that if you split things up, it's just going to use more steps, and that's okay. But both of these used the definition of midpoint. So I could split those into 2 separate steps, or I can put them together. All right, so just doing a check on what we have. I now have all 3 sides listed as corresponding parts. So I've got 3 sides, but I still only have 2 angles. So these angles, I have 1 more set of angles that I need to say are congruent. And that's going to be the angles right here in the middle. So if I look at those, based on the diagram, I have enough information to say that these angles are going to be congruent, but I have to know what kind of pair they are. So if I look, the angles I'm talking about are MON and POQ. So those are going to be congruent just based on how they're placed in the diagram. So angle MON is congruent to angle POQ, and I have to look at their placement to figure out what kind of angles they are. So they meet at a single intersection. So that's one of the first set of angles that we talked about. And they are across from each other, so they only share a vertex. Those are called vertical angles. So those angles will be congruent by the vertical angle theorem. So with that, that finishes off so that I have 3 congruent segments, 1, 2, 3, and I have 3 congruent angles. So now I have enough to use the definition of congruent triangles. So all sides and angles have one corresponding congruent side or angle in the second triangle. So I am ready to use my prove statement. Triangle MNO is congruent to triangle QPO. So since that was our prove statement, we're going to write it exactly like they have it labeled. And our reason there is the definition of congruent triangles.